Okay, this final video is the last problem on practice test number 2, which is number 13, which is our multi-loop circuit. Remember that these circuits here, we don't have resistors in parallel or series, so we have to use the multi-loop circuit approach, which is applying Kirchhoff's loop and junction rules. So we look at our goal is ultimately to find the current I2 that is running through R2. So here all the currents are defined. I1 is running through R1, I2 from R2, etc. So right away I'm just going to label my currents. So I'm just going to suppose that it comes out of the positive lead of the battery or EMF, and then I1 is the current going through R1, and then I2 is over here, and then I'm just going to suppose that I3 going through R3 is up this way. The next thing to do for Kirchhoff's voltage loop law is to label the potential drops in the resistors. So here we have current 1 as it goes through R1, then it's going to drop in potential from plus to minus. On I3, it's this direction. For I2, as we go down, it goes from plus to minus. And then here we already have the battery potentials labeled. So what we want to do now is start writing our laws. We have 3 unknowns, I1, 2, and 3, and we need 3 equations. So we'll start with the loop law. And let's start with loop 1, which I'm going to call this one over here. And I go around and I trace the loop, and notice it goes, as I go around there, it has basically E1 minus I1 R1 minus I3 R3 equals 0. If I put the numbers in, then I get 6 minus 2 I1 minus I3 equals 0. I can then do loop 2, which I'm going to choose over here. You can choose any closed loop, but I'm going to choose this one over here. And for that, I get E2 minus I2 R2 minus I3 R3 equals 0, because I go around this loop. So I can put in our numbers again. It's going to be 9. Oops. Excuse me. Let's see. This here should be R2. So it would be 9 minus 4 I2 minus I3 equals 0. The additional law is I'm going to look at this node right here and or junction, and I'm going to write the law for that the currents going in are equal to those going out. So I3 is equal to I1 plus I2. So now at this point, I've done the physics. It's just time to do the math. So I'm going to feed the junction equation into each of these for I3. Okay, I'm trying to solve for I2, so I'm going to try and keep that in my equations. So if I put those in, then I get 6 minus 2I1 minus I1 plus I2 equals 0. That then simplifies to 6 minus 3I1 minus I2 equals 0. And then over on this side, I have 9 minus 4I2 minus I1 plus I2 equals 0. So that simplifies to 9 minus I1 minus 5I2 equals 0. And now I have two equations and two unknowns. I want to keep I2, so I'm going to multiply this equation by 3 so that I can eliminate I1 from the equations. So if I multiply this one by 3, then I get 27 minus 3I1 minus 15I2 equals 0. And then if I just recopy this equation here, 6 minus 3I1 minus I2 equals 0. And then I'm going to subtract them. Then I get 21. These cancel to 0. Minus 14I2 equals 0, which tells me that I2 is equal to 3 halves. So you can always go back and plug into, if you have time, to some of these other equations and make sure that they're all consistent and give you a consistent set of solutions for I1, 2, and 3. Okay, that's the end of our practice 2 videos. Thank you.